And now, for your viewing and listening pleasure, here's Mr. Beebe.
How about that, Mr. Wirch appearing on a guest appearance on our video today. Thank you, Mr.
Is there
Wirch.
video?
It's a video and
Did I get on the video?
well, you don't get this, not your face, thank goodness, but just you, our voices, our
I
little.
think they want to see my face.
I don't think they do.
I think they do.
Okay, enough of that. He just really wanted to be included in our math class, so you know. Anyways, we are looking obviously at perimeter and surface area of similar figures. We just finished talking about similar figures, looking at perimeter and surface area, and I would like this to be a little bit more inquiry based. In other words, going to be let you do some investigations here. So we're going to find the relationships, or you're going to find the relationships, and we'll start that right now. Okay, so we have three squares. Yeah, we're going to call them squares. And I'm just going to put some measurements on here. There you go there. And so what I want you to do really quickly is to find the not the surface area, the perimeter. Find the perimeter of all three of those shapes, starting with the small one here. And then I want you to compare the perimeter of the other ones and see if you can find the relationship between the perimeter of similar figures. These are obviously similar figures. They have the same ratio corresponding sides. This one is times 2. This one is times 3 of my original figure. So see what happens with the perimeter in the same terms. Go. You have 3 seconds. Well, pause the video, then you have more time, but I'm giving you the answer in 3 seconds. Go. Okay, well, the perimeter of a square is simply, we're using squares, by the way, squares and circles in a bit here, just because they're really easy. But the perimeter of a square is 4 times the side length, so this is going to be 16, this is going to be 32, and this is going to be 48. Okay, and so we notice, hopefully, that to go from here to here, I just went times 2, and my perimeter also went to times 2. From 4 to 12 is times 3, and from 16 to 48 is also times 3. Okay, and so the relationship for perimeter of similar figures, if you double, it's a 1-to-1 ratio, right? If you double the side length, you'll double the perimeter. Okay, and the question we have to ask ourselves here now then is, does it work for circles as well? So there you go, two circles, one's 3 times the size of the other. Calculate their circumference, the perimeter of a circle, and see if you get the same thing. Go. Okay, well, obviously we get the same thing. Circumference is pi times diameter, or 2 pi r. And if you just leave the pi as like a variable, you get 6 times pi for the circumference of the smaller circle, and 18 times pi. In other words, this here times 3, just like this is here times 3. Okay. Well, that's really cool. That's one is done. How about area? Let's look at area first of all these ones here. Oh, and by the way, let's just talk about units for a second here. If this was in centimeters, my perimeter is in centimeters. Okay. If this radius here is in centimeters, then my circumference is also in centimeters. That'll become important a little bit later. So let's look at some area then. Okay, so for these shapes here, 2 squares and the 2 circles, figure out the area of each and see what the relationship is there. Okay, so in other words, for the squares here on the left, I am increasing my side length by a factor of 3. What's the increase in the area? Here I'm increasing my radius by a factor of 3. What is the increase in my area? I'm going to stop the video here. The next video will pick up and answer this question. So go ahead.